Space. It seems to us that it's infinite. But is it really so? What if somewhere out there, billions of light years away, it comes to an end? And if that's the case, what lies beyond our understanding in our universe? Astronomers are searching for the boundaries of the cosmos, trying to find its limits. Today, their discoveries suggest that beyond the limits we have reached, something unimaginable is happening. Somewhere out there, in the depths of space, hides something vast and massive, an invisible force that attracts all the matter in the universe, including our own Milky Way galaxy. But that's not all. Perhaps astronomers have also managed to discover something even more mysterious. So, what is this unknown force, and is it capable of destroying all the matter in the universe? Astronomers often discover strange cosmic objects with the help of modern technology, about which we knew nothing just 10 years ago. This time, we will look at what lies far beyond the Milky Way, in the direction of the Centaurus constellation. Our galaxy's disk is filled with gas, dust, and stars, which obstruct the view from Earth in the optical range. However, with the development of radio astronomy and X-rays, astronomers have been able to peer far beyond our home galaxy. It turns out that our Milky Way and our neighbor, the Andromeda Galaxy, are moving towards the center of the local group of galaxies, located in the Virgo cluster. The Virgo cluster, in turn, is part of the Laniakea supercluster, which consists of over 100,000 galaxies. Somewhere out there, in intergalactic space, at a distance of approximately 250 million light-years from us, there is a gravitational anomaly known as the Great Attractor. The center of attraction for the Laniakea megacluster is the Great Attractor. Its estimated diameter is approximately 300 million light-years, and its center is about 147 million light-years from Earth. In this region, hidden behind gas and dust clouds, astronomers have discovered a large supercluster of galaxies known as the Norma supercluster. The mass of this supercluster is estimated to be trillions of times the mass of the Sun. However, later research revealed that there are far fewer galaxies in the region of the Great Attractor than previously believed. It was thought that the mass of this Great Attractor was more than 10 billion times the mass of the Sun. But additional studies showed that its mass is only 1/10 of the initial estimate. Most of the visible galaxies in the region were attributed to the Malmquist bias. It is known that the farther the cosmic distance, the dimmer the objects will appear. Therefore, even a decade ago, astronomers could only see the brightest objects, mistakenly associating them with closer areas of the night sky. As a result, some regions of space appear to be densely populated with galaxies. Thus, the Great Attractor, in many respects, might be a mirage, showing us something that doesn't actually exist. And it might not be just a super attractor, but rather a region of space where there are more galaxies than usual. Moreover, the mass of the Great Attractor is not large enough to pull local galaxy clusters towards it. So, what is attracting them towards the center of the Laniakea cluster? In search of an answer, astronomers began to look for a structure with stronger gravitational attraction, and they soon succeeded. They discovered the Shapley supercluster, consisting of approximately 20 clusters containing around 8,000 galaxies, located at a distance of 650 million light-years from Earth. The mass of this supercluster amounts to 10 billion solar masses, making it the most massive structure within a billion light-years of the Milky Way. Scanning the sky in search of the oldest cosmic light, the European Space Agency's Planck satellite captured unique images of the central part of the Shapley supercluster. The largest pink patches show two galaxy clusters, Able 3558 on the right and Able 3562 on the left, as well as a couple of smaller galaxy groups between them. Astronomers also discovered a group located in the opposite direction from the Shapley supercluster. This area has an extremely low density, known as the dipole repeller. It turns out that due to its immense gravitational pull, the Shapley supercluster attracts celestial bodies from this region of space. As a result, astronomers believe that the dipole repeller is likely devoid of matter because regions with low-density space repel matter just as regions with high-density space attract it. However, even the discovery of the massive Shapley supercluster did not clarify the entire gravitational web in the vicinity of the Great Attractor. Professor Matthew Collis from the University of Australia believes that part of the Milky Way's velocity still cannot be explained. To reach this conclusion, the researcher calculated the gravitational force of the Virgo cluster, the Great Attractor, and the Shapley supercluster, and they do not align. According to Collis's calculations, our galaxy should be moving slower by about 50 kilometers per second. Professor Collis believes that this is related to mysterious structures hidden beyond the Milky Way. Astronomers have managed to find one of them, the Vela supercluster. This supercluster is located beyond a thick layer of dust and gas in the constellation of the Sail, approximately 850 million light-years from Earth. It is enormous, with dimensions reaching approximately 370 million light-years in diameter, and it contains about 100,000 galaxies, each of which shines with billions of stars. The gravity of the Vela supercluster explains the difference between the actual velocity of the Milky Way and the rate of universal expansion. Astronomers studied 883 galaxies in the zone of avoidance, a third of which had not been observed before. The study was conducted using the Parkes radio telescope located in Australia. Initially, scientists managed to detect 3 galaxy clusters, NW1, NW2, and NW3, and then 2 more new clusters, CW1 and CW2. On average, each galaxy contains 100 billion stars, and the discovery of hundreds of galaxies not very far from our own galaxy signifies an incredible amount of mass about which astronomers knew nothing. Nevertheless, the Milky Way continues to move faster than it should, and scientists are still searching for hidden sources of gravity while also uncovering the nature of the Milky Way's and other galaxies' motion within the local group. Researchers suggest that dark matter might be involved. Its gravity is capable of attracting galaxies just like massive structures made of ordinary matter. Alternatively, the speed of galaxy attraction could be accelerated by another theoretical force of the universe, the dark flow. This term was coined for clusters of galaxies connected by threads of hydrogen that are moving towards an unknown center of mass beyond the visible universe. Scientists from NASA's Goddard Space Flight Center discovered signs of this phenomenon by analyzing data from the Wilkinson microwave anisotropy probe. This is a vast study that encompasses a significant portion of the observable universe. The study's authors stated that the dark flow extends much deeper into the universe than previously thought, reaching 2.5 billion light-years from our solar system and heading towards the Great Attractor, then towards the Centaurus and Hydra constellations. According to one theory, this enigmatic dark flow is linked to some other world in a hypothetical multiverse. It's hypothesized that our universe grew from a single primordial energy field, and other universes could have formed from other energy fields. The dark flow might have been created by the gravitational attraction of some mass from a parallel universe. According to Professor Laura Mersini-Houghton from the University of North Carolina, the stream of galaxies could be caused by the gravitational attraction of a nearby parallel universe that is in gravitational interaction with ours. Meanwhile, an interesting study related to the Great Attractor was conducted by an international group of astronomers. They observed 10,000 galaxies and their clusters within 350 million light-years of Earth. Researchers tracked the motion of galaxies, starting from when the universe was only 1.5 billion years old up to the present day. They calculated the trajectories of galaxies, including the Milky Way, based on their current brightness and positions in space. As a result of the study, scientists discovered that all clusters in individual galaxies are moving towards some center of attraction. It might be some sort of cosmic black hole, or it could be something else entirely. It could be anything and everything. But at this moment, we know that the universe still hides many, many secrets, and scientists' attempts to unravel these mysteries lead to even more questions. What other cosmic phenomena would you like to learn about? Please write about it in the comments. To all those who watched this video to the end, thank you for viewing. Until our next, even more fascinating encounters.